Hey, what's up, guys? Today let's look at the link code number 76, longest increasing subsequence. Um, we're given a sequence of integers and we need to find the longest increasing subsequent. We call it LS, list. Um, so we should return the length of the LIS, list. Let's just directly jump into this example. For example, you have a sequence of 5, 4, 1, 2, 3, and the list is what? Is 1, 2, 3. So we will return 3 because the longest increasing subsequent is 3. And for second one, if you have a sequence of 4, 2, 4, 5, 3, 7, and the list is what is 2, 4, 5, 7. So we should return 4 because 4 is the length of the list. So how do we resolve this problem? We have to use dynamic programming. Why? Because we don't have to return the list. We just need to return the length of the list. So we don't need to return the specific solutions. We just need to return the length. Actually, dynamic programming is good at this. If you want the length, want just a final value, and dynamic programming is the one you should think of that. Second thing is that you can, from this question, we have to, find the list, the length of the list. Actually, it's easy for us to, figure out the state transfer equations between them. That's two strong signals. One is we just only need to figure out the length. Second is it is a list. So for the list, we know that the elements relationships between each other. We know that in the list, the later elements should be greater than previous elements. So that's the state transfer equation or relationships. As long as we have both, then we think dynamic programming is worth of a try. So that's why we choose the DP for this problem. Okay, so let's see how do we do this. For DP, we need to answer 4 questions. Definition, answer, state transfer equation, and initialization. So once we answer this 4, we're good to go. The first is dynamic definition. We have to use DP, and we're going to have to initialize a DP array. First, we need to make sure that what is the dimension of this DP array? Because in this problem, we're only dealing with this, one dimension array or sequence. So for our DP, we just also, initialize the one dimension. So second is that since your DP is one dimension, then we need to calculate all of the values in the DP. We need to specify what does it mean for DPI. And when we try to give the definition to the DP, we always actually started with the target. What do we have to do? We need to figure out the length of the list. So based on our target, so we define our DPI in this way. DPI is that we jump from index 0 to I, the length of the longest list. And there's a note. The DPI actually require us to, the list actually end with I. So that's our definition. So the answer, our answer is to figure out the longest list of the whole array, and the whole array, the list can end with any point. End with any index. So so our answer should be in this way: max DP. Actually, you probably also say this before. Our answer could be like a max or main of the whole DP array. This is one of the examples. So the answer is max DP. I put the comment here because the longest list could end with any index. Generally speaking. So we just use the max to get the longest list length. All right, so this is done. Third one is state transfer equation. In this problem, we need to find a list. A list actually is a subsequence, and a subsequence does not require each element they're adjacent, right? They just maintain the sequence order, but does not require each element to be adjacent. So for state transfer equation, actually for us, it's hard for us to figure out the dpi and dpi minus 1 or dpi plus 1, their relationships. It's hard for us because of this problem characteristics. So instead, we will use the intermediate states. We were trying to figure out the dpi with its intermediate states, let's say j. Okay, for index I, if we can find the intermediate states j, the j actually obviously between 0 and I. If we can find this j, its value, which is num j, if its value less than current index num I, then we can see that j and I, they can be in the same subsequence. Then dpi could be updated with dpj plus 1 because dpj has the subsequence has a length, but since j less than num I, so j's the list can expand to I, so dpj plus 1 can be dpi. Who knows? So there is a possibility we can use dpj plus 1 to update dpi, or we just use dpi's original value. So dpi's value can be updated with this main dpj plus 1 and dpi. So this is the state transfer equation we figured out, because we figured out the current dpi with its intermediate state dpj, and we have the equation here. So that's great. Once we found this equation, then we resolve the step 3. And the last step is initialization, because we have the this equation. The equation is going to use our previous state, so we have to initialize some values, because this is one-dimension array, and we just rely on one state dpj actually. So we just need to initialize the first first value, but since again we have to go back to the problem characteristics. dpi actually means the the length of the list and with that index. So at least it could be just a 1, right? I mean, if we end with I, at least this list can contain itself, right? So it could be I. It could be 1. So that's why we just initialize everyone with 1. It's quite different from previously what we did. We usually just initialize them with 0, but this time, according to the rule cases, we just initialize it to be 1. All right, so initialization is done. Now let's look at the code. Longest increasing subsequence, this is our entrance, and we were given the nums. And first we just do the parameters checking if this array is empty. We don't have to do anything. We just return 0. The list is 0 because it's empty. All right. If we pass the parameter checking, then we just initialize. First, we initialize our dp array. Obviously, the size is exactly the same as the given array, and we initialize every element with the value 1. So initialization is done. And then we need to use the for loop, because we have this much of numbers in the array, so we just need to calculate each dpi. Usually we just use for loop, so that we're trying to calculate the dpi in this for loop. But like I mentioned, it's hard for us to find a state transfer equation between I plus 1, or I minus 1. So we need to find another intermediate state, which is j. So we have another for loop. So j actually is from 0 to I. So j is the intermediate state. we have a condition here. If the intermediate state j, we found that nums j less than nums I. That means that j and I, they can form a list, or they can be part of a list. Then we'll be able to update update DPI. I'm sorry. So this part actually is a max. Yeah, because we're trying to get the longest. So if you found this satisfies, then DPI can be updated with max DPI or DPJ plus 1. Yeah. So once this nested for loops completed, then we have all of our values, filled in the DPI. So our answer will be, like I mentioned, will be return max DP. All right, so that is the one. So I also kept some notes here. Okay, let's try to run this. Looks like fine. Looks fine. Looks fine. Okay, that's great. So 100% test cases passed and then accepted. Yeah, so that's today's algorithm. Also, I have some short notes here. Yeah. All right, thanks. Have a good one. If you like this video, then please subscribe. Yeah, and I will just continue with this algorithm video tutorials. And thanks. Bye-bye.